Hello everyone, this is Nash. Today in this video, I'm going to show you a high DC voltage multiplier. In order to do so, we need two types of components. One is the capacitor and the other is the diode. In order to go deeper, I need to help you quickly review what is the basic function for the capacitor and for the diode. In my previous video, the physics and mathematics of RC circuit, I'd introduce you about the basic characteristics of capacitor. It's just like two parallel metal plates. It can help us to store the charge and build the potential. And for diode, like a silicon diode or germanium diode, due to its reverse bias mode, it can control the direction of the current, which means the current can only flow in direction which is now pointing to. If the current will want to flow from the opposite direction, the reverse bias in its reverse bias mode, it cannot, because the diode is going to block the current. So by using these two components today, I can not only convert the AC signal to DC voltage, and I can even amplify to increase the voltage, increase the DC voltage. So let's check how exactly is going on. So let's give it some number. Let's say this is your C1, capacitor 1, this is C2, capacitor 2, and this is diode 1 D1 and diode 2 D2. Since this is an AC signal, it's now changing its polarity all the time. So the current is going to flow in different directions as time goes by. And usually it could be a sine wave or a square wave, that doesn't matter. If it is a sine wave, your AC signal is going to change the polarity all the time. So since it's a sine wave, and let's say its peak voltage is about 10 volts, the peak voltage is about 10 volts. When the positive side is downward, like the positive side is downward, okay. And during the half cycle, the current is going to flow from the positive side. It can flow through D1. It can flow through D1 in the direction which is now pointing to, and then charge your capacitor 1. So on the right-hand side, on the right plates, it will store positive charges, and the other side will store negative charges. Okay, here we need to do some assumption. Choose assumptions. One, our diode, it's a kind of component, so it does cause the voltage drop. For silicon or germanium diode, it causes around 0.3 to 0.6 voltage drop. But in order to keep them simple, to make them simpler, we ignore the voltage drop across the diode and compare with the 10 volts, 0.3. I can fairly ignore that. And the second assumption is, if we want to charge a capacitor, we need some time. For instance, we need 5 time constant. Remember that? But usually time constant is really short, is really small. So I can assume that once the capacitor is now being charged, I can charge it to its maximum value immediately. So this is two assumptions. There is no voltage drop across the diode, and I can charge my capacitor with a very short time. Okay, with the two assumptions, we can keep going. So now the capacitor 1 is charged up to 10 volts, which is equal to the voltage supply of our AC signal. I got 10 volts. And now your AC signal is changing its polarity. So the positive side is going up. Okay, here's the interesting part. Since the current will flow from the positive side, originally the current is going to flow counterclockwise, and now the current would want to flow clockwise. So this is just like two batteries connected in a series. Two batteries, where are them? The AC signal is a kind of battery. It's first the battery. The positive side is attached to the negative side. Your capacitor 1 is going to play the role as another battery. So now this is just like two batteries connected in a series, and now they're both contributing the voltage toward the same direction. So 10 plus 10 equals 20. 10 plus 10 equals 20. And to make it more intuitive, I'll draw a diagram to help you understand. Your AC signal, the voltage is now pointing upwards, and your capacitor, positive and negative, is now pointing to the right. So this is just like two batteries connecting the series. So 10 plus 10, so 10 volts and plus 10 volts equals 20 volts. So the 20 volts are going to contribute along the cycle, and it's going to flow through D1. It's going to flow through D2, but however, it cannot flow through D1 since it is reverse bias mode. It cannot flow through D1. D1 is going to block the current, so the current can only flow through D2 and ready to charge your C2. So on the right plates is going to store positive charge, and the other plate is negative charge. And based on the Kirchhoff's law, the 10 volts plus 10 volts, they are both contributing the voltage to your capacitor 2. So the voltage stored across your capacitor 2 is 20 volts. No problem. So if you look at this point, let's call the point G point, is because it is now attached to the ground. And let's say this point maybe A point. So the voltage across the G point to A point, the potential difference across the 2 points is 20 volts. That's 20 volts. And if you want to measure the current flowing out and in from G point and A point, this is how we get the AC current. Since the current can only flow through D2, it cannot flow in the opposite direction. So this is how we get the DC voltage. The DC voltage is just a 10. And also the for the A point, the potential at A point is 20 volts. So compare with that value of your AC signal, it increased from 10 volts to 20 volts, twice the value of the regional voltage supply. So by using the diode and the capacitor can help us to store the potential, to store the voltage at the beginning, and later when your signal changes polarity, they can both contribute the voltage altogether and charge up the next capacitor and increase the voltage to increase the maximum value of the voltage. And your diode is just like a controller. It can control the direction of the current. Since now from G point and A point, the current can only flow through D2. It cannot flow in the opposite direction. So this is how we get this is the reference point. You can imagine this is some negative, and this is positive, and the current can only flow from the positive side. This is how we get the DC voltage, and thanks to the existence of our diode. But what if you want to increase more voltage, voltage that is high enough that can be called a high DC voltage? 20 volts is not that high, even though I have already increased the voltage up to 2 times higher. So I guess you can imagine what I'm going to do for the next steps. I'm going to cascade the series. I'm going to repeat the set to repeat the digits in series. Let's see what will happen. So I'm going to repeat this set. I got C1 and C2. Now I need another 2 capacitors. Let's call them C3 and C4. Okay, now I got another 2 capacitors. This is C3 and this is C4, and this is my diode 3, and my diode 4. Okay, I repeat the set. I cascade the series. Okay, check it again. If your AC signal is now changing its polarity again, the current reverse, the current is gonna flow from the positive side downwards. Let's see what happens. It's gonna flow from the positive side flow from the positive side, and it can flow through D3, right? It can flow through D3. So based on Kirchhoff's law, and in this cycle, the sum of the potential differences, the sum of the voltage is the 10 volts from your AC signal, is that pointing downwards, and the other one is your C2. They store the charges. They store the charges, and the positive side is on the right hand side. So they are both contributing their own voltage altogether, and the sum of them is 10 plus 20, which is 30. So they are going to charge the other components with their 30 volts, and they're going to charge the C1 and C3. C1 already got its own 10 volts, so we got 20 volts needs to be charged on this capacitor 3. So 10 plus 20 and minus 10, and that is equal to 20. So there will be 20 volts stored on capacitor 3. So now let's change the polarity again. The positive side is upward, and the current reverse. The current is going to flow clockwise. And let's see how much voltage we're going to contribute in this cycle. Since the current can only flow through D4, it cannot flow through D3. Since it's reverse bias mode, it cannot flow through D3. So I got 10 plus 10 and plus 20, which is 40. I got 40 volts to charge what? To charge C4 and C2. I got 40 volts to charge. And since C2 already got its own 20 volts, so I got another 20 volts to charge up my capacitor for. So this is G point attached to the ground. This is some kind of reference point. So this is 0 volts. So 0 volts, and potential increase 20 volts, and increase another 20 volts, which is 40 volts. So if this is B point, at B point I got 40 volts. See, I just double the value of the voltage at A point from 20 to 40. So this is how we increase the DC voltage. I not only obtain the DC voltage and by using the diode, and by putting another capacitors, the capacitors can help us to store the potential, to store the voltage, and later when your AC signal changes polarity, and both three of them, your AC generator and your capacitor 1 and your capacitor 3 are going to contribute their own voltage, like 10 plus 10 and plus 20, which is 40. They're both contributing their voltage to the same direction and ready to charge up your capacitor 2 and capacitor 4. So that's why the potential difference across your capacitor 4 is 20 volts. So from B to G, the potential difference across the G point and B point is 40 volts. This is how we increase the DC voltage. If it is not high enough, let's keep repeating the digits. Let's keep cascading the digits. So let me ask you a question. Since I know, compare with the original voltage supply, 20 volts means I double the value of the original voltage supply, and 40 volts means four times the value of the original voltage supply. So some of you might be wondering, what might be happen for the next point? This is A point, B point, and what happened if I get another C point? The C point, the potential for the C point, will it be 80? 2 times 40, will it be 80? Or 60? Or 60 means 6 times value of the original voltage supply. Let's check. If I repeat another set, I put another 2 capacitors and 2 diodes, like C5, C6 and D5, D6. Like this is my C5. I repeat the set, and this is all right. Doesn't matter. This is my D5. Repeat again. This is my D6. And this will be my C capacitor 6. Okay, I repeat it again. Check. if your AC signal is now changing its polarity again, the current flow from the positive side, So you can imagine the current is now flowing counterclockwise. So I got three components to contribute the voltage altogether, which is your AC generator. It contributes 10 volts, your capacitor 2, and your capacitor 4. Okay, I got three components to contribute the potential difference, to contribute the voltage, which is 10 plus 20 and plus 20. 10 plus 20 plus 20, which is 50. I got 50 volts to charge. To charge what? Ready to charge C5, C3, and C1. And since C1 and C3 got their own sum of voltage, which is 30, I got 50 to charge, right? So you subtract 30 from 50, leaves 20. So I can charge the capacitor 5 up to 20 volts. Okay, don't stop. Now your AC signal is changing its polarity again. The current is going to flow from upward, positive side is going to flow from the positive side and clockwise. Okay, it's now flowing. It's now flowing clockwise. Okay, so during the cycle, it cannot flow. It cannot flow through D5. It will block the current. However, it can flow through D6. So I got four components to contribute the voltage, which is your AC generator, your C1, C3, and C5, and the sum of the voltage is 10 plus 10 plus 20 plus 20, which is 60. I got 60 to charge. To charge what? To charge my C6, my C4, and C2. And since the sum of C2 and C4 is 40, and I got 60 to charge, so 60 minus 40 leaves, which is equal to 20. So your capacitor 6, number 6, will be charged up to 20 volts. So we are ready to talk about what would happen if I increase another stat, and now I get a C point. For A point is twice the value of the 10 volts, is 4 times the value of 10 volts. And what would happen for C point, for the potential of C point? Will it be 80? Will it be 60? So now the answer is quite apparent. I got another 20 volts, and positive side on right hand side, positive and negative, and which means the voltage is gonna increase 20 plus 20 plus 20 plus 20, and which means the potential, right, is C point is 60 volts, and 60 volts is 6 times the value of the original voltage supply from your AC generator. So now you can expect what might be happen to A, B, C, what might be happen to D point or E point. Then D point will be 8 times the value of 10 volts, and what will happen to the next is 10 times the value of the original voltage supply. So here's the thing, I am not doubling the voltage. At the beginning, it will be like I'm doubling the 20 volts to 40, but actually, I'm not doubling the 40 to 80. I'm just superposing. I'm superposing the voltage, and what I'm using is the capacitor, because the capacitor can help us to store the potential, potential difference, to help us to store the voltage at the beginning, and later when your AC generator changes polarity, and when your AC generator, the power supply, are pointing in the same direction as the other capacitors, they are both contributing the voltage altogether. This is how we superposing the voltage. This is how we increase and amplify the voltage. And thanks to the characteristics of our diode, the diode can only allow the current to flow in specific one direction. So this is how we get the DC voltage. For example, if I want to measure the current from G point and C point, this is positive from C point, and this is negative. This is negative. This is positive and negative. This is how we get the DC voltage. And if you keep cascading, if you cascade the series and extend the series as more as you want, you can keep increasing the voltage to maybe 1,000 volts or 10,000 volts. This is how we do that. But let me remind you, we are simply superposing the voltage. we increased the voltage, but we didn't increase the energy. So because P equals IV, so if I increase the voltage, and which means your current is gonna drop, drastically if you increase the voltage too high, because we are superposing the voltage stored on the capacitor. Maybe we are increasing the voltage, but however, your current is gonna drop simultaneously. Okay, this is our DC high DC voltage amplifier. Actually, it got another name called the cockroach multiplier. If you're interested, you can keep Googling it. So hope you understand how we convert the AC signal to DC voltage. This is because of the function of the diode, and simultaneously how we increase the voltage thanks to the existence of the capacitor, because it can help us to store the charge, to store the potential differences, to store the voltage at the beginning, and later when your AC generator changes polarity and when they are all pointing in the same direction, they are going to contribute their own voltage. This is how we superpose the voltage all together to increase the final output, high DC voltage. Okay, thanks for watching. This is Nash.